I'm going to talk briefly here about stability of a nucleus, and we want to look at something called the band of stability, because there are only certain nuclei are actually stable. It turns out that when something is radioactive, it's because there's an imbalance in the number of protons and neutrons, and we're going to look at the decay modes and see what happens. And we're going to find out some cases protons change into neutrons, other cases neutrons change into protons. And by doing this, we might be able to get back onto that band of stability. So here's the band of stability, and you can kind of see there's a line right here, and that is where the number of protons equals the number of neutrons. Because this whole graph here is number of protons, number of neutrons, and in the beginning, where the line has a slope of 1, then the first 20 elements or so, all the particles in here, and I'm going to emphasize the band with my black pen, pretty much whatever number of protons, they also have that same number of neutrons. So element number 12, magnesium, weighs 24, and element number 8, oxygen, weighs 16, all the way up to calcium, which is number 20, which weighs 40. Now after that, it turns out you need to have more and more neutrons in order to be stable. And after this point here, where you have about element 82, they're not even stable no matter how many protons you have. So, going back to our idea of the different kinds of decay, we've seen before that in alpha decay, 2 protons and 2 neutrons are ejected, and alpha particles ejected from the nucleus. So keep that in mind. During beta decay, we have seen this, and during beta decay, what happens is a neutron magically changes into a proton and gives off a beta particle. So we have a neutron changing into a proton. That's important. Now, during electron capture or positron emission, in both those cases, we have proton that changes into a neutron. Now, either proton changes into a neutron and gives off antimatter electron, that's a positron emission, or we have a proton gets an electron by electron capture, and then it turns into a neutron. Either case, proton changes into neutron. So proton changes into neutron, neutron changes into proton, or a particle is given off. So we can see what happens if we have the blue area here, where we have a nucleus that has a few too many neutrons. Well, then it might be pretty obvious then that all has to happen is if you can have a neutron change into a proton, that will get you more in balance, and that's what happens with beta decay. So if you're on this side of the band of stability, then you can do beta decay. In the same way, if you're over on this side, then you have too many protons. So if you have a situation where a proton ends up changing into a neutron, that would happen either in positron decay or electron capture. That would get you back on the band of stability. And finally, if you're past this point here, you're just too big. And if it's too big, you can go through alpha decay, in which case you lose 2 protons and 2 neutrons and get yourself smaller and back onto the band of stability. And that's the idea about stability.